class, we saw what is structure of nephron, JG apparatus and renal blood flow. To understand more about renal function, we need to know what is the mechanism of urine formation. For urine to be formed, which is around 1.5 to 2 liters per day, the three processes involved are in the mechanism of urine formation are: first is glomerular filtration rate, second is tubular reabsorption, and third is tubular secretion. In today's class, we will see what is GFR. GFR, today's class, normal values, factors and effective, and how it is measured. Glomerular filtration rate is the rate of formation of filtrate in all the nephrons in a unit time. Normally it's around 125 ml per minute, around 180 liters per day. So it is the formation of filtrate, plasma free filtrate. It doesn't have plasma proteins. Filtration fraction is the ratio of GFR by renal plasma flow. It's around 19 to 20%. What is it? It's around 19 to 20%. So there is also filtered load, the amount of any solute filtered per minute. So for any filtration to take place, there is a filtering membrane which comprises of endothelium of glomerular capillary. That is, in the glomerular Sand-Bowman's capsule, we have the endothelium of glomerular capillary, the basement membrane of the capillary endothelium, the interstitial cells, the basement membrane of epithelium of Bowman's capsule, epithelial lining of Bowman's capsule. So this is the filtering membrane. How does it look like? It is made up of fenestration, pores of glomerular endothelial cells, prevents filtration of blood cells but allows all components of blood plasma to fold. You can see the filtration slit and with pedicle and the podocytes. So we have a filtering membrane, enlarged view. So this is the filtration slit with the podocytes, the lumen of the glomerulus, and this is the filtration membrane. What are the forces acting on GFR? It can be the hydrostatic pressure. Why is it called ultrafiltrate? Because the pressure is more than 45 millimeters of mercury, so it is ultrafiltration. So the rate at which filtrate is formed is in all the nephrons in unit time. So we have hydrostatic pressure, colloidal osmotic pressure, the Bowman's capsular pressure, and effective filtration pressure. Along with this, these are the Starling forces. So we need to know that the factors which influence are also the renal blood flow, which is directly proportionate to GFR, the thickness of the filtering membrane, the surface area of the filtration membrane, and the size of the afferent and efferent arteriole. So we have the following forces: capillary hydrostatic pressure, colloidal osmotic pressure, and so the Bowman's capsular pressure. The thickness of the more thicker, the filtration will be less, and the surface area along with size of afferent and efferent arteriole with size and charge of the molecule with blood flow. So there are filtering forces and opposing forces. So how is GFR estimated? The substance used for estimating GFR or glomerular filtration rate is inulin. It is the Dalmia fructose. Inulin clearance is used to measure GFR. The substance should be non-toxic, freely filtered, should be neither secreted nor absorbed, and should not alter the function of the kidney, and should not be metabolized in the body. There should be an accurate and easy method to estimate the concentration of the substance. So if you take the amount of inulin filtered is equal to amount of inulin excreted. So GFR is equal to U into V by P. So GFR is measured by inulin. The amount of inulin filtered is equal to amount of inulin excreted, wherein the plasma insulin into GFR is equal to urine into the volume. So GFR is equal to U into V by P.